You have fallen into Event Horizon with John Michael Godier. John is joined today by Dr. Michio Kaku. Dr. Michio Kaku is a theoretical physicist, best-selling author, acclaimed public speaker, renowned futurist, and popularizer of science. As co-founder of string field theory, Dr. Kaku carries on Einstein's quest to unite the four fundamental forces of nature into a single grand unified theory of everything. His newest book, The God Equation, The Quest for a Theory of Everything, is out now.
Dr. Michio Kaku, welcome to the program.
Glad to be on the show.
Now, Doctor, you have worked for decades in the field of string theory. And string theory is, in some ways, a method of trying to unite general relativity and quantum theory, which are both two wildly successful theories that you can prove them and prove them and prove them. But in certain cases, at least general relativity begins to break down, such as the quantum level. Can you give us an overview of your work in trying to unify these together?
Well, it all began when I was 8 years old. All the newspapers were saying that a great scientist had just died, and they published a picture of his desk. On the desk was a book. It was opened, and the caption said, "The greatest scientist of our time could not finish that book." Well, I was hooked. I had to know what was in that book. Why couldn't he finish it? Couldn't he talk to his mother? Couldn't he simply look it up in a library? What's so hard? So I went to the library over the years, and I found out this man's name was Albert Einstein. And that book was to be the God equation, an equation no more than 1 inch long, perhaps, that would allow us to, quote, read the mind of God. Well, I was hooked. I had to know what was in that book. What could be so hard that the greatest scientists of our time couldn't finish it? So when I was in high school, I decided I want to pursue this as a job. So I asked my mom, I said, "Mom, can I have permission to build a particle accelerator in the garage? An atom smasher, a 2.3 million electron volt betatron." And my mom stared at me and she said, "Sure, why not? And don't forget to take out the garbage." Well, I took out the garbage. I got 400 pounds of transformer steel, 22 miles of copper wire, and I built the Betatron particle accelerator in the garage. Every time I plugged it in, I would blow out all the circuit breakers in the house. My poor mom, she must have said to herself, "Why couldn't I have a son who plays basketball? Maybe if I buy him a baseball, and for God's sake, why can't he find a nice Japanese girlfriend? Why does he have to build these machines in the garage?" Well, because of that, I earned the attention of a physicist who took me under his wing. His name was Edward Teller, father of the hydrogen bomb. He offered me a scholarship to Harvard. After I graduated from Harvard, he offered me a job. The job was to design hydrogen warheads. Well, I respectfully declined that very generous offer because I wanted to work on something even bigger than that. I wanted to work on the Big Bang, the creation of the universe. I wanted to work on this God equation, the equation that set the universe into motion. That's the power of this theory. It's a theory that drives the entire universe. So, well, that's what I do for a living now. I'm the co-founder of string field theory, one of the main branches of string theory. And we can get string theory down to about 1.5 inches in terms of its equation. We want to get it down to just 1 inch. We're not there yet. Now we know there's something called membranes that coexist with strings. And maybe somebody listening to this radio show will be excited by this and decide to finish the whole theory. Well, I have advice for you. If you ever figure out the God equation, then tell me first. We'll publish together and we'll share the Nobel Prize together.
Now, the God equation itself and reducing it down to, or reducing any of these theories down to a small 1 inch equation, or as I think in your book you say, a one sheet of paper, you can basically write down the fundamentals.
Yeah, that's a theory of almost everything, can be summarized in one sheet of paper.
Does that risk oversimplification, meaning that as Sabine Hossenfelder would say, that maybe this is a quest for too much beauty and that maybe it's messier than that, and maybe the answer lies in a 10-page equation? Is that equally possible or not likely?
Well, so far, all known physical phenomenon can be described by the theory of almost everything. It's the standard model with general relativity, but it's an ugly theory. It has 36 quarks and antiquarks, 20 free parameters that you can adjust, and 3 identical generations of subatomic particles. It's a clumsy, ugly theory. So we don't think it's a final theory. That's why we think that with symmetry, we get it down to 1 inch, not just 1 page. But the very fact that we can write down the laws of physics on 1 sheet of paper, the known laws of physics, is remarkable, absolutely stunning. The fact that you don't need 10 sheets of paper, 1 sheet of paper will tell you everything from the Big Bang to the end of the universe itself. But it's not the final theory. There's another theory out there, the Goddard equation, because the standard model with 36 quarks and antiquarks is a very clumsy theory. It's like taking an aardvark, a platypus, and a whale, scotch taping it together and declaring it to be nature's finest evolutionary achievement, the end product of millions of years of evolution on the Earth. No, the standard model only works at low energies. At low energies, it works. It describes subatomic particles. But maybe there's a new theory out there because we have a 5th force now emerging out of Chicago. Near Chicago, we have the Fermi Lab. And the Fermi Lab just 3 weeks ago, announced that there was an incompleteness in the standard model, a crack in the standard model. What does that mean? Perhaps it's the next octave of the string. Perhaps we're seeing the first experimental evidence that there's a higher theory out there, the theory that eluded Einstein, the Goddard equation, which I think is string theory.
String theory also addresses another question in addition to the 5th force, gravity. And gravity has been a pain, to say the least. Einstein spent his last 30 years of his career looking for a quantum theory of gravity, and it still eludes us. What are your views on that? How does string theory address gravity?
Well, first of all, what is string theory? String theory says that an electron is not really a dot particle at all. If you have a supermicroscope and could peer into an electron, you'd find that it's a rubber band. You twang it, it changes frequency, and you call it a neutrino. You twang it again, changes frequency, and you call it a quark. In fact, all the subatomic particles can be described as musical notes on a tiny vibrating string. So what is physics? Physics is the harmonies that we can write on vibrating strings. What is chemistry? Chemistry is the melodies you can play when these strings bump into each other. What is the universe? The universe is a symphony of strings. And then what is the mind of God that Albert Einstein wrote about for the last 30 years of his life? The mind of God, we think, is cosmic music resonating through hyperspace. That, we think, is the mind of God. Now, what I find absolutely astonishing is, if you take the lowest note, the lowest octave of the string, you find all of Einstein's theory of general relativity. This is amazing. If Einstein had never been born, I repeat, if Einstein had never been born, we would have discovered all of his theory of gravity as nothing but the lowest octave of a vibrating string. But the string has higher octaves as well, meaning that that could explain the 5th force, we think, which is emerging out of Chicago, and also dark matter. Invisible matter which surrounds the galaxy, holds the Milky Way together. The string theory predicts not just the standard model, not just Einstein's theory, but the next octave, which contains, we think, invisible matter called dark matter.
In regards to string theory, the big problem has always been testability. Do you think there'll come a time where we will be able to devise any kind of a test that at least hints that string theory is how the universe works?
Well, in my book, The God Equation, I had mentioned 5 ways that you can test this theory. 5 ways. First, you can look for deviations or cracks in the standard model of particles. And sure enough, as the book was going to press, we think we found the first major crack in the standard model, meaning that at higher energies, a new theory is going to emerge. Second, as I mentioned, dark matter. We are living in a wind of dark matter. It's invisible, you can't feel it, but your body is moving in a wind of dark matter. It's invisible, but what is dark matter? We think that one day dark matter will collide with a proton, will photograph the collision, and will identify what dark matter is. String theory predicts that dark matter is probably the photino, the next highest vibration of a photon. So we even have a candidate for dark matter. Third, baby pictures of creation itself. The European Space Agency and NASA want to launch LISA into orbit, Laser Interferometry Space Antenna. It is a gravity wave telescope in outer space. It is so accurate that it should give us baby pictures of the infant universe as it's emerging from the womb. And maybe, just maybe, we'll find evidence of an umbilical cord connecting our infant universe to a parallel universe. In other words, verifying the multiverse theory. Next, we have the fact that the Japanese, the Chinese, and the Europeans are now making proposals for the next generation of particle accelerators. The Large Hadron Collider verified the standard model, but it's very expensive. We need to have coalitions of nations to afford the next generation of particles, and that's what the Japanese, the Chinese, and the Europeans are not talking about. The next generation of atom smashers. And fifth, lastly, we can look for deviations in Newton's laws of gravity in your living room. You know, we verified Newton's laws of gravity out to the galaxies. Everywhere we look in outer space, Newton's laws of gravity seems to hold until, of course, we hit the speed of light. Then we have to use relativity. But it's never been measured in your living room. Do we really know that gravity diminishes at the inverse square in your living room? That's the next challenge, to see if Newton's laws of gravity really hold at small distances, like inside your house. Now, Newton's laws are what are called inverse square laws. You double the distance away from a star, gravity goes down by a factor of 4. But that's because space is three-dimensional, length, width, and height. If you have a 5, 6, 7-dimensional universe, then gravity diminishes as the inverse cubic, the inverse quartic, the inverse quintic. That's how fast gravity diminishes in these other scenarios. So by measuring deviations from Newton's laws of gravity in your backyard or your living room, again, we can test string theory. So those are 5 major ways that we can test this theory.
Now, on the subject of gravity, the big question has always been how general relativity views gravity, of course, as warps in space-times. But another question is, on the quantum level, is it a particle? Do you think that it is a fruitful search to look for the graviton? Or do you think it probably doesn't exist?
Well, the graviton is extremely hard to measure, but we think it does exist. The 4 fundamental forces, all of them, 3 of them, can be quantized, and we quantize them by chopping them up into particles, like light. A chopped up light beam is called the photon. The photon is a particle of light, a quantum particle of light. Now, gravity, if we quantize it, should also be chopped up into what are called gravitons. But you can calculate that gravitons are very hard to find, very hard to experiment with. But everyone believes that there is a quantum theory of gravity. So think of it. Nature has a left hand, which is relativity, the theory of the big. Nature has a right hand, the theory of the small, that is quantum theory. But these 2 hands hate each other. They don't combine at all. They're based on different mathematics, different principles, different concepts. But why would God make a universe where the left hand and the right hand don't talk to each other? That's why we need a unified field theory. And that's why physicists believe that there's a missing link that ties together the theory of the big with the theory of the small. That's why we believe that, yes, there is this higher theory out there. We can debate the nature of this higher theory, but almost all physicists believe that, yes, there's a higher theory out there. The standard model is simply too ugly and too crude to describe the entire universe.
Now, within all of this, you have historical cases where new physics reveals new things that we can use, or at least have to adjust for. And an example of this would be that Newton's assumption that clocks ticked at the same rate everywhere in the universe, which turned out to be an incorrect assumption. So now we have general relativity, and we have to sit here and adjust everything from GPS satellites and anything going fast. We have to make adjustments for general relativity. Within string theory, are there any apparent things that we could use in the future, any new features of physics that we could use in the future to do something like travel time or break the speed of light or anything like that? Is any of that present?
Well, the short answer is, for us, for you and me, the answer is no. Each solution of string theory is a universe, an entire universe. And therefore, to apply this theory, you have to have technology far beyond anything that we can muster. But this theory will ultimately answer the questions. What's on the other side of a black hole? Is there a white hole on the other side of a black hole? Does it connect to another universe? Are there parallel universes? Do we exist in a multiverse of universes? And also, what happened before the Big Bang? And if the universe is expanding, what is it expanding into? All these questions cannot be answered using Einstein theory. We have to go to a higher theory, and that's where string theory comes in. String theory says that, well, yeah, wormholes might be possible. We have to calculate the stability of these wormholes, but if they exist, maybe we can break the light barrier. Think about it for a moment. Some people think that we've been visited by aliens from outer space. Well, a lot of physicists roll their eyes to the heavens and just shake their head and say the distances are so far that aliens cannot reach us from the distant stars. But you see, that makes a mistake. That assumes that the aliens are maybe 100 years more advanced than us. What happens if they're 1,000 years more advanced? 1,000,000 years more advanced? Then they can take advantage of string theory. String theory exists at what is called the Planck energy, 10 to the 19 billion electron volts. That is a quadrillion times more powerful than the Large Hadron Collider outside Geneva, Switzerland. At the Planck energy, space and time become unstable. If I had a microwave oven and I simply heat a glass of water, first the microwave oven would make the water boil. Eventually it would ionize it, break it up into hydrogen and oxygen. Then it would rip off the electrons off the atoms if you keep on raising the temperature. Finally, the nucleus of oxygen breaks apart. Finally, you reach the Planck energy. At the Planck energy, bubbles begin to form inside your microwave oven because space and time become unstable. Bubbles begin to form. Stephen Hawking called it the space-time foam, that at small distances or high energies, space becomes foamy. And what are these bubbles? Gateways. Gateways to another universe. And then the next question you're going to ask me is Elvis Presley still alive in a parallel universe? Well, the answer is possibly yes. The king could still be belting out hits, not in our universe, but perhaps in a parallel universe as predicted by string theory.
I was actually going to ask if Elvis ever existed, and that existent timeline, does that indicate something, truly indicate something that happened in the past? So my question would have been, does Elvis exist? Or was he just a figment of our imagination?
Well, you mentioned timeline. That's very important. You see, Newton thought that time was like an arrow. You fire it, never deviates. It uniformly beats throughout the universe. Einstein comes along and says, not so fast, not so fast. Time is a river. It can speed up and slows down, creating a timeline that meanders its way across the universe. String theory goes even farther. String theory says that the river of time can have whirlpools, forks in the river of time. And that allows you to solve all the time travel paradoxes. What happens if you go backwards in time and kill yourself as a child? Well, if you committed suicide as a child, then how could you be around today to get into a time machine to kill yourself as a child? Well, there's a way around it. Because if the river of time forks into two rivers, then you have not really killed yourself. You killed somebody that looks like you, is genetically identical to you, has all the memories of your youth, but it's not really you. You committed murder for somebody in somebody else's timeline. So in other words, you cannot alter your own timeline. Sorry about that. But you can alter alternate timelines perhaps. Now, is that really possible? You can also calculate the energy necessary to do this, and it is the Planck energy, meaning that you would have to have a black hole. You would have to have a very advanced civilization to deliberately tinker with string theory. But I think eventually string theory may also save life in the entire universe. You see, according to physics, the universe is dying. It's getting older and colder. One day, all the stars will blink out. The universe will consist of dead neutron stars and black holes. All life will die when the universe itself reaches near absolute zero. But you know, physics is not necessarily a death warrant for intelligent life in the universe. There's one and only one way to escape the death of everything, and that is to leave everything, to take this equation, the God equation, to create a dimensional lifeboat and sail to another bubble, another universe out there, and start all over again where it's warmer. And we could mess up that universe as well. We'll have two universes to mess up. So string theory may also give us the only salvation for intelligent life in the universe.
Now, I have a couple of questions regarding that, because that brings in an interesting take on the Fermi paradox. Could it simply be that alien civilizations may be extremely rare? You know, there were a lot of, Earth had to jump through a lot of hoops to get to us. But say, for example, there are other universes, or perhaps there were universes previous to this one, to invoke Penrose. Could it be that the place to look for alien civilizations are ideal universes that perhaps they created or colonized and traveled to, and that the reason we don't see aliens is they've all left for a better place?
Well, let's talk about the physics of this. We physicists rank civilizations by energy, and we can then calculate what they can accomplish with this energy. A type 1 civilization has planetary energy. They control the weather. They can perhaps alter earthquakes and volcanoes. Anything planetary, they would control. Type 2 has exhausted the power of a planet, and they use the sun. They actually extract energy directly from the sun to energize their machines. Like, for example, Star Trek. Star Trek would be a typical Type 2 civilization. They've colonized a tiny fraction of the galaxy, but not much more than that. Then there's Type 3, galactic. They roam the galactic space lanes like Star Wars. Star Wars would be an example of a Type 3 galactic civilization. Or if you're a Star Trek fan, the Borg. The Borg would be a Type 3 civilization, and that's why the Federation lives in fear of the Borg. Now, what are we? We are Type 0. We get our energy from dead plants, oil and coal. We don't even rate on this scale. So now let's rephrase the question. At what civilization level can you create a wormhole to then leave our universe? That's the Planck energy, the energy of a star, the black hole. That's 10 to the 19 billion electron volts. You take out a calculator and you calculate, growing at about 3% a year, how long would it take for us to become Type 1, Type 2, Type 3? In about 100 years, we will become Type 1, unless we blow ourselves apart. You can calculate that we'll have planetary energy by about the year 2100. To be Type 2, it would have to be a few thousand years ahead of us. That's reachable, a few thousand years ahead of us. To be Type 3 galactic, you would have to be about 100,000 to 1,000,000 years more advanced than us. And so once you attain type 3 status, then you can play with the Planck energy. That is the energy of the string. And so if aliens from outer space could visit us or perhaps leave the universe, we know that they're probably type 3. They're probably galactic. They probably can play with black holes, and they probably use string theory in all their calculations.
Should such a thing exist, a very, very advanced alien civilization that spans the galaxy at type 3, do you think it's more likely to be a machine as opposed to biology?
That's a very definite possibility. If you look at the drones, if you look at the Navy pilots' videotapes of these objects that have been flying around, you realize that the G-forces inside these ships is sufficient to break the bones of any normal person. So they're probably mechanical. They're probably drones, or maybe half drones, half organic. And because, of course, the human body is very frail, and if you want to explore the universe, perhaps the most inefficient way is to do it with rocket ships that have G-forces, which can tear the human body apart. So yeah, I wouldn't be a bit surprised if a flying saucer landed on the White House lawn and the aliens came out, and we were shocked to find that they're not really organic, that to survive travel in outer space, they're part organic and part digital. However, I have a different way of exploring the universe. You see, the digital revolution will eventually digitize us. Our credit card transactions, our Instagram photographs, everything known about our digital fingerprint will be digitized to give us an approximation of who we are, a digital carbon copy of who we are. For example, I would love to talk to Einstein. One day soon, somebody will digitize everything known about him and create a copy of him that you can talk to. One day we will be digitized. And what are we going to do with it? We are going to explore the universe as digitized beings. You can put the digital you on a laser beam and shoot it to the moon. In 1 second, your soul, your digital soul, is on the moon. In 20 minutes, you're on Mars. In 4 years, you reach the nearby stars. No rocket misfailures, no explosions, no worries about weightlessness, no worries about suspended animation, none of that. At the speed of light, your digitized soul can explore the universe. And how do you do it? On the moon, there's a mainframe computer that will download your digital soul and put you into an avatar. This avatar is superhuman, super handsome, super pretty, and like Superman, can survive on any planetary environment. In other words, this is how I think the aliens will explore the universe. Forget the Enterprise, even forget flying saucers. We're talking about digitizing ourselves and at the speed of light, sending our digital souls throughout the galaxy. Now, all of this is well within the laws of physics. Now let me stick my neck out. Let me stick my neck out by saying that I think this already exists. I think this is the most efficient way for aliens to explore the universe. I call this laserporting, and it means that there's probably a highway, a laser highway maybe close to the Earth, where the souls, the digital souls of billions of aliens are going about their business, zipping across the galaxy at the speed of light, and we humans are so stupid and crude that we're just completely aware of the fact that this is probably how the aliens explore the galaxy at the speed of light. Think about that. Maybe they're already here because their avatar can exist on any planet. Their avatar can take any form. And of course, they may even want to blend in with the natives once they land on a planet.
So in one thing that comes to mind, and I have many questions regarding this, but one thing that comes to mind is that could make it a situation where SETI, looking for radio signals, is going to find them, and that the first thing it sees is a digitized transmission of a being in which you might have intercepted an alien traveling from one star system to another, and you happen to be right in the way, and all of a sudden you surprise the alien by decoding it, if you could, and printing him out, right?
Well, also, let me tell you something that makes people even more paranoid. Given the fact that you can download your digital soul into an avatar, the avatar could look just like the natives, just like ordinary people. Because you don't want the natives to get afraid and start to make trouble. You want to blend in. Just like people who go to Africa to photograph the lions and so on and so forth, they try to blend in a little bit. They don't want to disturb the wildlife when they go visit Africa. So maybe the aliens will simply assume the shape of a human, just like in Men in Black. The aliens are among us. They're avatars, digitized souls of alien creatures that look just like us.
So what would the aliens have to do to accomplish this? Now, I can think of a way. So early in their development, say they're a billion-year-old civilization, and they decided to colonize the entire Milky Way with von Neumann machines that can 3D print out copies of themselves, as von Neumann envisioned, but also anything else. And they could print out, a copy of themselves. They could print out custom drones to bother Navy ships. They could do any of these sorts of things, and that's well within the realm of physics as well, because the galaxy is only 100,000 light years in diameter, and if you got a lot of time, you can, at sublight speeds, fill the whole thing with von Neumann machines. Is that realistic?
And remember, the aliens don't have to be billions of years ahead of us to do this. Within about 100 years, I'm thinking about just 100 years, that's a hop, skip, and a jump, we will have the capability of digitizing ourselves and shooting our souls into outer space. That's how fast this revolution is taking place. In Silicon Valley, already companies are offering to digitize you. That is, everything known about your Instagram pictures and your cell phone transactions and what have you. So a digital soul is going to emerge very soon. And this means that your great-great-great-great-grandkids will want to talk to you because you'll be digitized, you're immortal, and they'll be able to download your digital version and have a nice conversation with you sometime in the future. So I think within 100 years, we'll have the capability to digitize our souls, shoot it into outer space. That we can do now, by the way. We can already put that information on a laser beam and shoot it to the moon. What takes more time is to have a mainframe on the moon to then download your digitized soul and then put you in an avatar that can then thrive on the moon, Mars, or what have you. That may take a few more 100 years. So in other words, we don't have to wait billions of years for this to happen. Just a few 100 years, and I think that is the method of choice. If I was an alien civilization, this is how I would explore the universe, on a light beam, as pure energy, traveling at the fastest velocity, sub-light speed, actually at light speed. And I think that's how the aliens will explore the universe.
The other problem being is that we see no evidence for it. So that would be a solution to the Fermi paradox in itself, in that one possible solution is they're everywhere, they're here, they're walking the earth.
They're just avatars.
Yeah, they're avatars, and
they look just like us.
So indistinguishable that we would never be able to distinguish that you were looking at an alien and that you just thought it was a human.
Just like Men in Black.
Now, Doctor, to get back to string theory, another aspect of this is dimensions. And string theory usually projects, 10 plus 1 of time, something along those lines. Now, what is string theory's view of other dimensions?
Well, if you take the 4 fundamental forces and try to put them together, 3 dimensions, there's not enough room. The theory cannot fit together if you just use Scotch tape. That's called a standard model. Very clumsy, awkward. But if you go to a higher dimension, then these forces begin to simply fit together like a jigsaw puzzle. I like to think of it this way. Let's say there's a flatland where 2-dimensional people live on a sheet of paper, and there's a beautiful crystal hovering above it, which was unstable. It shattered into 1,000 pieces, raining pieces of crystal on flatland. So over hundreds of years, the flatlanders pieced together painfully all these pieces. After many decades of hard work, they have 2 big chunks of the crystal. The first chunk they call relativity. The second chunk they call the quantum theory, and the 2 chunks do not fit together. No matter how hard they try, they cannot fit together. And then one day, one of the flatlanders says, let's move the chunk into the third dimension. Well, the flatlanders say, that's ridiculous. There is no third dimension. You're a crackpot. There's no third dimension. There are only two dimensions, length, width, forward, backward. That's it. And the guy insisted, no, build a computer. Build a computer that will then put the two pieces together. And so they did. They lifted one piece into the third dimension, turned it upside down, and the two pieces fit perfectly. In other words, in 10 or 11 dimensional hyperspace, there's enough room to fit all the forces of the universe. It fits like a jewel, reassembling the universe ever since the Big Bang broke the symmetry of the original universe 13.8 billion years ago.
In regards to the supposed fifth force we were discussing, now, the one thing that sets gravity apart from the other forces is its incredible weakness. Does that seem to be also the case with the Chicago claims of the indications of a fifth force? Does it appear to be like gravity and extremely weak, or does it appear to be strong?
Well, first of all, the standard model is a low energy theory. It works for energies up to about 14 trillion electron volts. That's not even close to the Big Bang. But hey, that's all we can do as Earthlings on the planet Earth. So the standard model works up to 14 trillion electron volts. But beyond that, new forces could emerge. And these forces in turn are mediated by particles. And that apparently is what happened just 3 weeks ago outside Chicago at Fermilab. They found that the magnetic properties of the muon, a partner of the electron, disobeyed the laws of the standard model. So this is big news, a fifth force beyond gravity, electromagnetism, and the two nuclear forces may have been found, meaning that there's a higher theory, a theory that works at higher energies beyond 14 trillion electron volts. And remember, string theory predicts many octaves. In fact, an infinite number of octaves, just like an infinite number of notes on a violin string. And we think that this could be the photino, or something similar to the photino, a particle predicted by string theory that is the next vibration beyond the standard model. That's why people right now are breathlessly working to see how we can fit this new piece of information and how we can explain a possible fifth force.
Now, in your new book, The God Equation, The Quest for a Theory of Everything, you go in a surprising direction and ponder something that normally you don't find in a book on physics, but you do hear it murmured every so often, especially by Albert Einstein, the idea of a God. Do you think that the position that, say, Stephen Hawking took, where there's no room for a God, or the position where Einstein was talking about the God of Spinoza and a sort of interesting but not religious way of thinking about a God, do you think any of that is a valid question to ask, or do you think that since it's not testable, it doesn't mean anything?
Well, I think these are valid questions. As Einstein himself said, science without religion is lame, but religion without science is blind. So Einstein did not believe in a personal God that gives you a bicycle for Christmas, that smites the Philistines. No, not a personal God, but the God, as you mentioned, of Spinoza, the God of beauty, harmony, simplicity, elegance. You know, the universe didn't have to be like this. The universe could have been messy. It could have been random. It could have been chaotic, devoid of any life. But here we are. The universe is gorgeous. It's teeming with life. It is gorgeous and beautiful and has all sorts of symmetries and unexpected, delightful facets to it. And that's why Einstein thought of himself as a little boy entering a library, a huge library with all the wonders of the world. And all he could do was take the first volume, first chapter, first paragraph, and read a few lines. And so I think that Einstein realized that, yes, there could be a larger design to the universe, and he wanted to find the God equation. Now, the God equation is not God. It's what set the universe into motion. In other words, if you are a God and you want to create a universe, you have to have the equations that allow you to do that. And that's where the God equation comes in. Now, I think Galileo said it best. Galileo said that the purpose of science is to determine how the heavens go. The purpose of religion is to determine how to go to heaven. So, in other words, science is about how the heavens go, natural law. It's about the laws of atoms and the laws of planets and stars. Religion is about how to go to heaven. In other words, ethics, how to be a good person. The problem is when people who are in the sciences begin to pontificate about ethics, or when religious people begin to pontificate about natural law, that's where we get into trouble. But as long as we keep these two domains separate, they are complementary. I don't see any contradiction at all between the two.
Now, this has been said. I interviewed Brother Guy Consolmagno at one point, who is the Vatican's chief astronomer, and the Vatican does legitimate astronomical research. And throughout that, they say there is no conflict between science and religion because they do not look to describe the same thing. And that science is limited specifically by testability and what you can measure, things like that, whereas religion is not limited by that. But I have to wonder if you do indeed find a theory of everything and you can fit it into a 1-inch equation. That's beauty on level that goes above just simply looking at the universe and saying that galaxy is beautiful. That's actually a level of beauty above that, the simplicity of the universe and how it can be, expressed like that, if we are ever able to do that. Do you think that in itself is an indicator of some kind of intelligence behind the universe? The beauty of it, the simplicity of it.
Well, let's talk about beauty. To an artist, beauty is something that is aesthetic and pleasing to the senses. But to a physicist, beauty is symmetry. Very simple, symmetry. And symmetry allows you to combine vast amounts of data to find the pattern, the simple pattern that makes everything work. For example, Newton unified heavenly physics with Earth-like physics and found that they obeyed the same laws. He had a symmetry that allowed him to unify heaven and earth. And then Maxwell unified electricity and magnetism. Again, a unity of two objects creating a symmetry between electricity and magnetism. And then Einstein comes along and says E equals mc squared, revealing the symmetry between m, which is the mass of the sun, and E, which is the energy of sunlight. So in other words, throughout physics history, we see that the fundamental guiding principle is symmetry, unification through symmetry. Now we have all these subatomic particles, and how do we make a symmetry out of this jungle of subatomic particles? Well, if I have an equation, the God equation, that contains all these particles, and I rotate the equation, I make a transformation of the equation, and the equation rotates into itself, that's it. String theory is exactly like that. String theory takes all the subatomic particles as musical notes, rotates them into itself, just like a snowflake. A snowflake you can rotate by 60 degrees and it turns into itself. That's why snowflakes are beautiful. Kaleidoscopes are beautiful because you can rotate it by, let's say, 30 degrees and it remains the same. That's why kaleidoscopes are beautiful. Well, string theory is gorgeous because it takes the entire universe and rotates it into itself. It is the largest symmetry in the history of science. The largest symmetry ever conceived of by the human mind is contained within the music of vibrating strings. And that's why I say that symmetry is more than just a pretty topping that you put on a dessert. No, symmetry is the guiding principle that made possible the theory of gravity, the theory of electricity and magnetism, the theory of energy and matter, and now all of subatomic particles and general relativity can be summarized as musical notes.
I wanted to ask you about another thing that we had briefly talked about, the idea of technological development and reaching a certain stage within 100 years that would allow for things like exploring the galaxy digitally. What's your take on the concept of a singularity? Do you think that technological development is moving faster and faster, or is it going to hit some sort of a level where it doesn't become incomprehensible, as Ray Kurzweil would say?
Well, the short answer is I don't know. However, let me introduce the concept of physics into this. You see, the word singularity comes from physics. Singularity was first introduced to describe the center of a black hole. But then, of course, people in the computer sciences borrowed the term from physics, and now it means the point at which machines equal or surpass the intelligence of humans. Some people say that by 2045, machines are going to be smarter than humans. But you see, you have to be careful, because how do you come up with that number? Through Moore's law. Moore's law says the computer power doubles every 18 months. You know more or less the speed of thought, and how long will it take for computers to reach that speed? And you come up with a number around the year 2045. But that assumes that Moore's law continues. It's slowing down now. Why? Because of quantum mechanics. When transistors get so small, you don't know where the electron is anymore. The electron leaks out, and the uncertainty principle kills you. That's why Moore's law cannot last forever. Already it's slowing down. The people who work with semiconductors admit, yes, it's slowing down. And so a lot of these projections about the singularity have to be modified to take into account the fact that Moore's law will eventually collapse for two reasons. One, heat generation will be so high, it'll melt the silicon. And second of all, more important, silicon itself cannot sustain calculations at the quantum level. Your PC has a chip with layers of semiconductors about 20 atoms across at the minimum. 20 atoms across. In the coming decades, it'll be 5 atoms across. At that point, leakage takes place, the Heisenberg uncertainty principle takes over, and your computer collapses. Now, there's a dark horse out there, quantum computers. So if the quantum theory kills you, why not use it to create the next generation of machines? Well, there's a problem. And that is that quantum computers that powerful don't exist yet. It's a big question mark whether or not we can build quantum computers that are comparable to the computing power of the human brain. It's not known at the present time.
All right, Doctor, we are out of time. Everybody should check out Dr. Kaku's new book, The God Equation, The Quest for a Theory of Everything. And it really is an interesting book that goes into the history of that search, which has been going on for a very long time now. Doctor, thanks for joining us today, and I hope you'll come back when the next book comes out.
Okay, well, thank you very much for putting me on.
Thanks to Dr. Michio Kaku for joining us today on Event Horizon. Be sure to subscribe so you never miss an episode.